Okay, so this is day 46 in our integrated math class. We're going to be talking about rate of change and slope today. So our objective, well, there's a standard, but I want us to read off the objective down here. So let's all read that off together. Out loud, ready, and begin. Okay, good. So that's all we're going to do. Raise your hand if you've seen slope before. Okay. Raise your hand if you've done the math, like a math class, and they talked about slope. Some of you? Okay, cool. Not all of you. Can someone give me an example of where you might see a slope in real life? Yes. A slope with money?
Like how the stocks go up.
Okay. How stocks go up? Yeah, that's right. So you could look at the increase. That's right. That's a good example. I like that. Yep.
Ramps for wheelchairs.
Ramps. Oh, ramps for wheelchairs, right? That's a good one. What happens if they make the slope wrong? They can't go up quickly, right? Or if it's too steep on the way down. Yeah. Now, what happens if they make the slope too shallow, like for a ramp? Like, it's really long, like a really long ramp, or maybe it zigzags, but it's really shallow. Is it very easy for the person to get up?
Yeah.
Yeah, but does it take a long time?
Yeah.
Yeah, what if you're a builder? Would you want to use that much space to make a ramp? No, so you have to make the perfect amount of space, or use the perfect amount of space and make it shallow enough so it's easy enough. Does that make sense, everyone?
Yeah.
Good. All right. So, oh, that's not what I wanted. Pause the video here. Let's have students write down the steps up here really quick, please. I'm going to pause the video. Okay, so we see slopes in real life a lot. You should have those steps written down. Also, like when you might go skiing or something or snowboarding, and you're like, oh, I'm going to go down the slopes, right? So there's different angles in the mountains, as you're going down, maybe on your skis or snowboard. So a steeper slope, right, is make you go faster, right? Shallow slope will make you go slower. Same idea as the wheelchair ramp. Very good. So, numbers 1 and 2. I want to show you how to do numbers 1 and 2, okay? Okay, eyes up at the screen, please. So, today we're going to look at the graph and identify what the slope is by looking at the graph, okay? So, there's 2 points here. The first thing I want to do is identify what my points are. So, I look from the origin. This is back to like 5th grade math. Okay, eyes up here. Thank you. Eyes up here. Thank you. Pencils down. You're counting to get to this point. This is negative 1, 2, 3. And then down negative 1, 2. So this point is going to be negative 3, negative 2. Okay? This point up here, I'm going to start again and go 1, 2, 3, 4, up 1, 2, 3, 4. So this one is going to be 4, 4. Okay? Then I want to count my rise over run. So I'm going to start at 1 point, okay? So I'm going to go up 1, 2, 3, 4, 5, 6, right? And I know I'm rising 6, okay? So I'm going to put that down. Then I'm going to run from where I left off, 1, 2, 3, 4, 5, 6, 7. And I'm going to put my run down as 7. Does that make sense, everyone? Then I'm going to put my final answer as rise over run. So, then we're going to write our final answer as rise over run. We're going to put m is equal to our rise over run, which is 6 over 7. And that's it. Okay? So we could look at this a couple ways. We could look at this as elevation. Okay? We could say that maybe this is like the steepness of like a skateboard ramp, right? For every 6 inches, or for every 7 inches you go to the right, the ramp goes up 6 inches. That's kind of a steep ramp, right? Or here's another way to look at it. Ready? Let's pretend that girls represented X and boys represented Y in the population of students in San Dimas. So, for every 6 boys, how many girls will there be? 7. Does that make sense? It's kind of like a ratio. Okay? Cool. So that's number 1. Watch me do number 2 one more time. Number 2, we got 2 points here. I'm going to identify the points here, just like on number 1. Okay, and then I'm going to start counting. I'm going to pick a point, okay? So on this one, I'm going to start down here again. Figuring out my rise. 1, 2, 3, 4, 5, 6. So I'm rising up 6, and I'm going to write down 6 on the side there. And then I'm running only 2, right? So my rise over run is 6 over 2. So now I got a question. Is this fraction simplified? No. What can I do to simplify it? Good. So it'd be like saying 3 over 1. So, but I'd like you to write your slope as a fraction always, even if it's a whole number, 3 over 1. Because the numerator represents rise, and the denominator represents run. Okay? Does that make sense, everyone? All right, cool. Let's hear some talking today. Let's start with the 4s. Switch things up today. 4s are going to talk first. 4 is going to talk about number 1, and then if there isn't a 4, let's have a 2 talk. And then once 4s are done, let's have 3s talk next. 3s will go next. 3s will talk about number 2. Ready, set, and go. Okay, number 3. Number 3. So we got identify the slope, okay? So working with your, I'm going to hide that one. Working with your group, why don't you figure out what's the slope of this one? I'll give you about 30 seconds. Go. So that's number 3, and there's number 4. Everyone's working on number 4 now. Here we go. You should have had this. Eyes up here. The rise is going to be 6, and the run is 2. I'm sorry, rise is 4, run is 2. Can we simplify 4 over 2?
Yes. Yes. 2 over 1.
So our answer is going to be m is equal to 2 over 1. I know you could just say m is equal to 2, okay? But we're saying m is equal to 2 over 1. Number 5 now. Okay, so I got a question for you. Remember how on these problems, like on numbers 1 and 2, we figured out the points, and then we kind of like, we figured out the points, and then we figured out how much the rise of a run? You see that? What would you do, talk to your group, what would you do if like you had, what would you do if you had the points but you didn't have the graph? Talk to your group about strategies. What would you do? Okay, what would you do, kids? What would you do? Raise your hand. Let's get some volunteers to tell us what would you do. Take a chance. Yep, Tommy.
You do the y1.
Oh, like a formula?
Yeah.
Okay, that's one way. What else can you do? Yes?
Y2 minus
X
y1.
with X and Y with Y.
Okay, subtract x with x and y with y. Good. That's kind of like what Tommy's talking about. Any other ways? Can we graph it and then count it? Yeah, that takes a lot of work. You could also use Desmos. All those are okay. Now, here's the way you could do it. I don't know if it's the best way. I think it's the fastest way. And this is what Tommy described earlier. Is the following. Oh, sorry about that. If these are our points, right, and I think you were talking about this too, right? Subtract x with x.
Yeah.
Okay. So, isn't rise just the difference of the numbers? Don't we count to find the difference? So we could take the y2 minus y1, or the 2 y's, right? Bring them and subtract them. What's y1 minus 13? What? Negative 12, right? And then I could do the same thing with my x's. Negative 18 minus negative 3, right? As my denominator. Okay, which is going to be negative 15, right? And what goes in both 12 and 15, everyone? 3, right? So 12 divided by 3 is 4. And then 5 divided by 3 is 5. So what's a negative divided by negative? So that's our answer to number 5. Okay? Does that make sense? Okay, so why don't you discuss this? Let's have 2s talk about this in their groups. Teaching the rest of the group, how did I just find the slope without using a graph? And then everyone's writing this down. Ready, set, go. So I'm doing that. Can't I just mark all of these up? Okay, so I just walked around. There's a lot of you that just sat there and didn't do anything or didn't try anything. So let's try this again. Let's give you another minute to finish up your work. So you should have the following. You should have, eyes up here, checking your work. -2 minus -1, or -1 is the first part, and then we got -15 minus -13. What's -2 minus 1? -3. -15 minus -13 is -2. What's a negative divided by a negative? Positive. Can I simplify 3 over 2? No, that's your answer right here. Okay? A lot of you got it right. Raise your hand if you actually put like a negative. Okay. Does this make more sense to you now? Okay, good. All right. That concludes the lesson.